In this video we will examine saving a model in TensorFlow, a trained model, and exporting it for use by applications to make predictions. So the first thing I'm going to do is log in using default username password admin, and I'm going to use the demo deep learning project we can see here on the right hand side, and that was created by running the deep learning tour on the left hand side. So we're going to go into that project. Now the first point to note is that this particular example is going to use Python 2.7, so I'm going to have to change the version of Python from Python 3.6 to Python 2.7, and I could do that by going down here to Python. Now I have already customized this particular Python environment, so when I try and remove Anaconda, what will happen is that it will in fact have to delete the old version of my Conda environment first, and then after that we'll be able to work with Python 2.7. So I just activated Anaconda and selected Python 2.7. So what it will do is remove my old Anaconda environment for this project, the demo deep learning Anaconda environment, and we can see it's gone, and now I have Python 2.7. We can see that that's here, noted here. So now I'm going to start up the Jupyter Notebook, and I'm going to select these. I can use the experiment option, and I'm going to select a driver with 4 GB and an executor with 4 GB with 1 GPU. So let's click on the start button. It's going to start a new Jupyter Notebook. You may have to authorize opening a new window, a new tab. In this case it didn't do it because I haven't actually authorized. I'm going to click on that. I clicked on, just to show you again, you can click on this button here to open Jupyter Notebook in a new tab, which I did. And I'm going to go to the serving folder down here where we have a few examples of how to serve notebooks. So we have one called train and export model, and I think the same notebook is in here. So we can just open that one there. So I'm going to just start it running immediately and then explain what's happening. So this is a Python 2.7 notebook. We can see we have our training function called wrapper here, and this is going to run on the executor. And if we go down this, you can see it's the MNIST example. So it's going to take the MNIST data in. We're going to go down, it's going to train the model, and what we can see down here is we have this TF save model builder to save the model, and we've passed it an export path. So that export path, if we examine it, comes from the work directory, and that work dir, if we search for it, comes from the current working directory. So in this case it's just going to take the train model from the local path of the executor in the cluster, and after that we're going to have to save it, but we want to save it to HDFS rather than to our local path, because we'd like it to appear in our model's data set, and this is the command we'll use at the end. And what we can see is that we're giving a name for the model and a version number. So this model will be called MNIST, and the version number will be 1. So there's a little bit more code in here. This is using the TensorFlow Serving API. We've also got the Hopsworks serving part. So if we have a look for the Hopsworks serving part, we can see that we're only using this serving function at the end to save the model back to Hopsworks. Otherwise it's just normal TensorFlow code. Okay, so this is currently training. It's finished actually. You can see that the experiment is finished, and what we can do is we can go back to the Hopsworks browser, and we can see that the executor is still, the GPU is still allocated because it hasn't timed out yet, so it'll time out within 60 seconds. And what we can go directly to now is the Datasets View or service, and in here we have a dataset called models, and that's where our model will be saved. So if I open up the model, we can see in here we've got the dataset was created we have a folder in here that was created called mnist, and this will contain our model. So let's go in there. And inside there we've got a version, so if you have many versions of the same model, they'll get stored in different directories. And we can see here that the model itself is a protocol buffer file as well as some variables. So the variables, if we go in here, you can see that there's a couple more files that are needed for serving. Now these files in place, this model file, it can be used directly in a Spark application. So in a batch application you can use this file and you can import it into your application and make predictions. But if you want to serve it over the network, you'll need to use model serving. So there's a service here on the left called model serving to serve models that have been trained and stored into HDFS. So let's go over here to model serving, and model serving supports two different platforms, TensorFlow and TensorFlow Keras, and also sklearn or scikit-learn. So you can see there's two options here. TensorFlow. I'm going to pick TensorFlow, and what we'll do is, so we pick the TensorFlow option, and we click on this model button here, and we need to select our model. So we go to the models folder, and we go to mnist, and this button here turns green. That means we can click on it, and then I click on that, and now we've selected our model. We can give the model a name. I call it mnist, and we've only got one version, so we pick that one version. If you're using the enterprise version at this point, you'll be able to have a you can select how many instances of this model you'd like to run. It's going to deploy a Docker container on Kubernetes in the enterprise version. In this particular version, it's just going to run a TensorFlow Serving Server locally. And what we can also do is we can create a Kafka topic to store the logs for all requests made on this model. So this will do it automatically, and we just pick one partition and replication factor of 1. In a production setting, you might have more partitions and a higher replication factor, such as 3. Let's just go ahead and create the model. And that's it, the model's been created, and we can press run to start the model serving, and that model can now be used in an application. So if we click on the detailed information, we can see an endpoint with which we can use in our applications to make predictions. If we want to use if it's a model for classification, we'll use the classify endpoint, and if it's for regression, we can use the regression endpoint. We don't need to worry too much about the internal serving port that this is running on. The Kafka topic name we can use if we want to monitor this particular model that's running. So we can have a Spark streaming application that reads from this topic and then maybe notifies if the model's performing poorly or if it needs retraining or so on. So once we have that endpoint, we can create an inference token, and this inference token we can use in our application. It's a JWT token, and the application can now make inference requests on this endpoint from outside of Hopsworks. So it uses the endpoint that we got from over here, detailed information, and then it uses this inference token that we just had. So that's it for model serving for now.